Here we're going to review literal equations and formulas. So for some reason, students always see these problems like what's in example 1 and 2, and they get scared because there's all these variables. And I want you to know that these are not scary. All a literal equation and a formula, both of them, all that that means is that there's more than one variable. So could be just two, could be three, could be four, but it just means that there's more than one variable. So you can still solve these equations, you're just not going to get a numerical answer, because when you're getting a variable alone and there's other variables, your variable that's alone is going to be in terms of the variables that remain. So you are actually going to do absolutely nothing different here than what we did when we solved one variable equations or inequalities. We're just going to use those opposite operations. So example 1a, this is a literal equation because it's not a formula for something, and it has more than one variable. It has x's and y's. Always make sure you pay attention in your quiz and your test which variable it says to solve for, because that's what we want to get by itself. So in this case, it's telling us to solve for y. So that means that I want to get y all by itself. So if I want to get y by itself, that means I need to move this 6x. Right now that 6x is positive, so that means that I have to subtract to get rid of it. So minus 6x minus 6x, these are going to cancel away. Now again, here's where people get all confused because they're used to things having like terms to combine with. This 15 and this negative 6x are not like terms. So it is perfectly fine. You're going to leave them separate. So what I've got on the left now is negative 7y. And so you can either write 15 minus 6x, or you could write negative 6x plus 15. Those are the same thing and it doesn't matter. Now, y is still not alone. I have not solved for y, so I need to get rid of this multiplied negative 7. Oftentimes I'll get people adding this because they see the negative. The operation between that negative 7 and the y is not subtraction, it's multiplication. So we undo that with division. Now I picked this one purposefully because here's another place where sometimes I see students get confused. These not like terms. Most of the time in the choices of the answers that you're going to see, they're going to separate the pieces. So you have to divide both of these terms, because they're two separate terms, by this negative 7. So you do 15 divided by negative 7. That doesn't come out evenly, and it doesn't reduce. So you're going to leave it because your answers are going to be in fraction form, not decimal form, unless they tell you otherwise. Then I look at the next term. So yes, I still have the x, but the numbers are the coefficients. So I deal with them separately. So negative 6 divided by negative 7. A negative divided by a negative is a positive. 6 and 7 do not have any common factors, so it stays 6/7, and then I just bring the x along. So I get this. Remember that it could also be written 6/7 x minus 15 over 7, and that would be equivalent. So I've done what it asked. I have solved for y. Y is now alone. Again, I'm not going to get a number answer. I'm getting an expression in terms of the other variable. So B, is actually much, much easier to solve, but it has no numbers, all letters, so just want to be prepared for that as well. We want to solve this for H. So I look at H, the B is what's keeping it alone. They're right next to each other, which means that they're multiplied. So I undo the multiplication with division. So dividing both sides by B, cross those out. So again, these are not like terms. They're not the same variable. So I can't combine that A and that B. So I have A over B equals my H, which of course, sometimes in your multiple choice answers, they'll switch the order around. And so you might see it like this instead, but they are equivalent. All right, last one of this type, we're solving V equals pi r squared h for r. Both B and C are formulas. B is the formula for area of a parallelogram or a rectangle. And C is the formula for volume of a cylinder. So in this case, we want to solve for r. So pi is technically a number. It's multiplied by that r squared. So is the h. Because they're both multiplied, I can get rid of both of them at the same time by dividing. So if you want to do it one at a time, you can, but since it's the same operation, you can go ahead and just divide both of those away. Again, not like terms. There's nothing I can do to simplify what's now on the left. It's going to stay V over pi h, and now equals r squared. Now, I have r squared. I need r. So we undo squareds, you learned in Algebra 1, with square roots. So I'm going to square root both sides. Now, again, I try to pick very purposeful examples here because you're definitely probably going to see something, either an equation or a formula with a square root. Whenever you solve by taking square roots, you have to put in a plus or minus on the other side. So the square root and the squared undo each other, so that gets my r alone, but I need a plus or minus on the other side. And so you can write it like this. Now we haven't reviewed simplifying radicals yet, so I would guess that you would not need to do anything to simplify here, but just so you know that that's the same as putting, you know, the two different square roots here as well. If you want to rationalize it because you remember how to do that, that's fine. But I would guess that because they haven't reviewed that in this course yet, that the expectation would probably not be to do that. So I would think that this answer right here would be acceptable, but for those of you who remember and want to review, this is a rationalized answer. All right, last one. The formula that relates cylinder area to cylinder diameter is A equals D squared times 3927 over 5,000. Find D when A is 7,854 square centimeters. So a lot of times when we're working with formulas or with literal equations, they'll give us that formula or equation and then ask us, you know, to find one when you know the other. So this is just a plug and chug. So I'm going to plug in 7,854 in place of my A. And I don't need to put the label in there. Area is always square units. And so this is D squared times 3927 over 5,000. So if I'm trying to figure out what the diameter is, I'm trying to get D by itself. So that means I need to get rid of this multiplied fraction. And in the other videos, I reviewed that the way that we get rid of multiplied fractions is either dividing by that fraction if you're using a calculator that has a fraction button, or by multiplying by the reciprocal. So here, the reciprocal would be 5,000 over 3927. These cancel each other out. Whatever I do to one side, I also have to do to the other. So really, I'm just multiplying these two numbers with each other. Now, you can use a calculator here. Let me pull my on-screen one up if you would like. Of course, it's going to validate the software. There we go. So on the TI, I do alpha y equals, choose the top one for fraction. So numerator is 5,000, denominator 3927, and then I'm going to multiply that by 7,854. Now here we're extremely lucky. That came out to be a nice complete whole number. That's because 7,854 is double 3,927. So those came out super nicely for us. We've got 10,000. So that means that 10,000 equals diameter squared. So then, just like up here, we're going to undo the squared with a square root. And typically we do the plus or minus. Now, in this case, I want you to realize that the only reason our final answer isn't going to have this plus or minus is because this is a real life situation, and a diameter is a distance, it's a length, it cannot be negative. So we can cross off the negative, and so square root of 10,000, so here since I've got 10,000 there, I can just do square root of the answer, and that also nice number, and that's 100. It's my guess that if it's not going to come out nicely, they'll tell you what to round to, you know, in nearest centimeter, nearest tenth of a centimeter or something like that. But in this case, it came out nice and even for us, so the diameter would be 100 centimeters. All right, that wraps us up. Let your teacher know if you have any questions.